Lesson 11, reciprocal and multiplicative inverse, order of operations, identifying multiplication and addition. Okay, that seems like we're going to have to do a lot, but don't worry, I don't think it's as long as this is alluding to or making us think. So here we go. Reciprocal, to invert a fraction, means to switch the numerator and the denominator. Some people say flip it upside down, okay, but it means to switch. Can you read that? I cannot tell anymore. I'm not sure how good my lighting is, so hopefully you can see. So switch. All right, here's another way to say it. If one fraction is the inverted form of the other one, so if you invert a fraction, it is called the, write this correctly, reciprocal. I know you've heard that before. Make sure you can spell it. All right, now we have special cases. There, it's right here. 0 is the only real number that does not have a reciprocal. Okay, so 0 is the only real number that does not have a reciprocal. Like, what's the reciprocal of 4? Right? You might think, how do I flip that? It doesn't have a denominator. Every whole number has a denominator. Mathematicians are a little bit lazy, and if we can leave it out, we do. So we don't want to put it over 1 because that's too much work. We would just want you to know it's there and it's invisible. Okay, so if we inverted or found the inverse or the reciprocal or the multiplicative inverse, then it would be 1/4. Okay? So if we had 0, 1 over 0 is its reciprocal. Now that is meaningless. Write this down because you cannot divide by 0. And then I'm going to say this again. Ever. And then as Taylor Swift would say, like never. Like never ever. Gonna get back together. Or divide by 0. Same thing, right? Okay, fancy math language definition. You're going to see this in your book a lot, so I'm just going to call it what it is. Some people like to sound smart and make things sound very complicated, and math books are great at that. Okay, so in the book it says, for any non-zero real number A, the reciprocal or multiplicative inverse of the number is 1 over A. Okay.
For any non-zero real number A, the reciprocal blah, 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 blah,
right.
blah.
Okay, all they're saying is for any number, if you put it under the number 1 or flip it, it's the reciprocal. Okay, so A, 1 over A was the reciprocal. So just, I don't know why it has to be so difficult, but there you go. Now, what happens when we multiply a number by its multiplicative inverse? Okay, so here are examples. Let's try it. These are all 4 and 1/4. Those two are multiplicative. I'm going to struggle with that all night. Multiplicative inverses of each other. So what happens when we multiply? Okay, remember we multiply straight across, and here's this invisible one that mathematicians don't want us to have to write because we're lazy. So if we multiply straight across, what happens? We get 4 over 4, which actually equals 1. All right? Let's try it on this one. Okay, let's multiply straight across. So we get negative times a negative. We get 2 negatives, so we're going to have a positive 5 over a positive 5, which reduces to 1. Well, look at that. Do you see a pattern? I do. When you multiply, we get a 1. When you multiply a number by its reciprocal, it looks to be the answer is 1 every time. Okay, so this is the other way around, right? Negative 1/13, the reciprocal is negative 13. So now we have multiply straight across, and we have 13/13, and then we get 1. Now we go to the second page, order of operations review. Okay. In the past, you've done order of operations. Some of you might have heard of the thing called Pemdas. Pemdas, which is a cool acronym. What it means is you do parentheses first, exponents next, multiplication, division, addition, subtraction. I don't know anymore in my old age if I like this acronym or this way to explain it, because I see a lot of mistakes when people go take this literally. Okay, so maybe think like parentheses mean any symbol of an inclusion, and we'll do that in one of the next lessons. And exponents is part of some, anyway, inclusion, but don't worry about that. What I want to say is multiplication, division, addition, and subtraction. People think that you always multiply before you divide, and that is not true. What it means is you multiply or divide before you add or subtract. Okay? So whatever comes first from left to right, you either multiply or divide. Okay? You don't always multiply before you divide. It depends on who comes in front. So let's just do a few of these and see if it makes sense. All right, so I look at this and I'm going to simplify it. First, my eyes scan, and my eyes are directed over into this area and then this area, because I noticed those are multiplication operations, okay? And the rest is addition. So I'm going to take care of these things, and I'm going to write another line, okay? When I do these, they tend to filter down to a point. I'll show you what I mean. We'll get 12 plus 2, and then this is, you could say plus negative 15 or minus 15, okay? So I'm just going to do that. And I'm going to turn my phone off before we hear lots of that. Okay, and now we have addition and subtraction. So we do whatever comes first. So from left to right, I see, oh, okay. Actually, addition and subtraction, we can just call it all algebraic addition, but I'm getting ahead of myself. Let's just go from left to right. So then we get 14 minus 15, and that simplifies down to a negative 1. Okay, next one, simplify. Okay, again, I see this is multiplication and this is multiplication, so I'm going to take care of those first. I'm going to call that a negative 10 minus 3 and plus 18. Okay, now I'm just going to go from left to right, or group up like signs, which we've done in the past. Okay, this is negative 13 plus 18, and that simplifies to opposite signs. So 18 wins, it's going to be a positive 5. Okay, why don't you try the next one? Go ahead and pause me and see if you can get the right answer on this one. Okay, and go. Okay, so let's see how you did. Maybe you'll notice here we've got multiplication, multiplication, and multiplication. Okay, now this is 12. Now some people might get confused by this. Is it minus 2 times 5? Well, anytime there's something in front, that really does mean negative 2 times 5. So here's how we can write it. Negative 10. Okay, this might take some getting used to. Plus 6, nothing happened with the 6 yet. He didn't get to play. And then same deal. I'm going to call negative 5 times 2. Okay, is a negative 10. You see that? Now we have all addition or subtraction. But now that we're doing algebra, there's really no subtraction. It's all just adding negatives, right? Okay, so we can go from left to right. Or like we said, I can notice that these two are negatives and these two are positives, and they can say, hey, I see you over there, let's group up. So I'm going to do that. The 12 and the 6 make an 18 positive, and the negative 10s make a negative 20. Okay, and I go ahead and get a negative 2 from my answer. Okay. they just wanted, I added this on there just for you to see when it's addition and subtraction or when it's multiplication. Okay, notice there's nothing between the 3 and the 5. Okay, it means multiply these. So this is this is multiply. I'm gonna put a dot up there. This is multiply. Even though there's a minus here, it's got a parenthesis. So this means 7 times -6 or -7 times -6. So this you're just going to have to get used to. This is 4 times -5. These are times, okay? And that's a -4 times. So if we were to evaluate this, we're going to get 4, and this together makes -15. This together makes plus, well, I just forgot, it's 42, right? And -4 and -5 is a positive, 20. Okay, now we've gotten rid of all the multiplication, and now we're just adding up terms here, or numbers, okay? So I noticed that 4, 42, and 20 are all positive, so I'm going to combine those. Okay, 4 and 42 is 46, plus 20 is 66. Okay, so that means I have a -15 and a 66. Or it could be 66 minus 15. Order doesn't matter when we're doing algebraic addition, okay? So that is pretty new. It's a big jump from old school addition and subtraction to algebraic addition. Okay, so then we combine those, and I get the 6. It's going to be positive. 6 minus 5 is 1. So we get positive 51 on that. Okay. I want you to try the practice now and see how it goes for you, okay? So go ahead and pause me and come back and check your work, okay? All right, so you should have paused me, and now you have done them, and you're going to check. All right, so I see multiplication and multiplication. So what that simplifies to is 18 minus 4 times 5 times 6. 20 times 6 is 120. Okay, now I see my answer is going to be negative because 120 wins. It's going to be a negative 102. Okay. Letter B, I see multiplication and multiplication. So I'm going to do those first. My eyeballs went straight to those spots. So I have 15. The 2 didn't get to play yet. And this is you could say plus -8 or just -8. Okay, this might be bothering you, so I do want you to let me know if that happens, okay? You will be watching this in class while I'm there, so I want to make sure that this makes sense, because I'm not writing plus -8 anymore. I kind of took the training wheels off, maybe too early. I'm not sure. We'll have to see how it goes. So that simplifies to 17 minus 8, which is 9. Okay. Now I look at this, and my eye gets drawn to here, this grouping and this grouping. Okay, so I have 8 minus 6 minus 7 plus 10. And so 8 and 10 make 18. And the 6 and 7 make 13. And I get a 5. Okay, now you might have had some of this a little different. That's important that you have the same right answer at the end. Okay, my eye's drawn to those. So 13 didn't get to play yet. This is 20, and this is negative 30. Okay, so 13 and 20 is 33, minus 30 is 3. Okay, so again, I'm going to be there in class today if you were doing this in 2015, the fall of 2015, and I can answer any questions. All right, enjoy.